Good day everyone. Today we are excited to present to you Simpson rule, one of the most widely used numerical method in calculus. Our team consists of myself, Sharmila, Kantharubi and Machni. Together we will present our findings on Simpson rule. Our presentation will cover two main aspects of Simpson rule. First, Simpson 1/3 rule. Second, Simpson 3/8 rule. These are two variations of the method, each with its own unique advantages. Let's start with a brief introduction. Simpson rule is a numerical method used to approximate the integral of a function. It is especially helpful when the function is complex or cannot be integrated analytically. Unlike simpler methods like a trapezoidal rule which approximate the area under a curve using straight line segments, Simpson rule uses parabolic segments. This makes it more accurate as the parabola better fits the shape of most curves. In essence, Simpson rule divides the integral into segments, then applies quadratic polynomials to approximate the function over those intervals. This approach significantly improves the precision of the integration.
Let's take a look at the Simpson's 1/3 rule. This is the formula for the Simpson's 1/3 rule. To find the value of h, we have to subtract b and a and divide it with n, where h is equals to height of the interval and n is equals to number of the interval. There are few terms in this formula. Let me explain each one. y0 is first value of y, where yn is the last value of y. y1, y3 and y5 are odd y's, whereas y2, y4 and y6 are even y's. To get a deeper understanding of the Simpson's 1/3 rule formula, let us take a look at the example question. This is the example question. So the question is evaluate the value of integral of 0 from 1 2 over x to the power of 3 plus 1 dx using Simpson's 1/3 rule. So as the first step, we have to find the value of a, b and h. From this question, we know that the value of a is 0 and the value of b is 1. To find the value of h, we have to minus b and a and divide it with n. As we know, b is 1 and a is 0, now we have to find the value of n. In this case, n is determined upon choice. So for this question, we have determined n as 6. So the value of h will be 1 minus 0 divided by 6, which will give us an answer of 1 over 6. So the value of h will be 1 over 6. Since n is equals to 6, we have to find the value of x and y from x0 to x6 and y0 to y6. To find the value of x, we have always to keep in mind that x0 will always be 0 and x1 will be x0 plus h. So in this case, the value of x1 will be x0, which is 0 plus h, which is 1 over 6. So x1 will be 1 over 6. We have to follow this exact same method for all the x till x6. To find the value of y, we have to substitute the value of x into the equation, where the equation is 2 over 1 plus x to the power of 3. So for y0, we have to substitute the value of x0, which is 0, into the equation, which will give us the answer 2. So we have to follow this exact same method for all the y's till y6. Once we have find all the values of x and y, now we have to convert the values of x to two decimal point values, which will make it easier for us to solve the problem later. Once we have find all the values of x and y, now we can start to solve the problem. So as first step, we have to substitute all the y values from the table into the formula. So once we have substituted all the values into the formula, now we have to solve all the equation in the parentheses first. Once we have solved all the equation in the parentheses, we have to solve the multiplication equation in the bracket. Once we have solved the multiplication equation in the bracket, now we can add all the values in the bracket. Once we have added all the values in the bracket, now we have to solve the h over 3, which is 1 over 6 divided by 3. If we solve 1 over 6 divided by 3, that will give us an answer of 1 over 18. So to find the final answer, we have to multiply 1 over 18, which is h over 3, with 32.1, which will give us the final answer of 1.783. This final answer may vary according to the decimal points we are choosing, but the first two values of the final answer, which is 1.7, will always remain the same. The values after 1.7 may change.
Let's move on to Simpson's 3/8 rule. The formula Simpson's 3/8 rule is a numerical integration method that provides an approximation for the integral of a function over a given interval. Unlike Simpson's 1/3 rule, which uses quadratic polynomials, parabolic arcs, Simpson's 3/8 rule employs cubic polynomials, cubic arcs. This method is particularly effective when the number of subintervals is a multiple of 3. Here we can see the formula fx dx 3h over 8 and fx0 plus 3 multiplied by fx1 plus fx2 plus 2fx3 plus fx6 and plus with 3 fx4 fx plus 5 and so on. H is equals to b minus a over n is the width of each in subinterval, and the number of subintervals must be a multiple of 3, and x0, x1 and xn, the points dividing the interval a, b. We should take consider of the endpoints fx0 and fxn. It should be multiplied by 1. And the intermediate points like x1, x2, x4, x5 must be multiplied by 3. Points at multiples of 3 like x3, x6 must be multiplied by 2. Wait in Simpson's 3/8 rule for each group of 3 subintervals, 4 points. Now let's take a look at one of the example question. The question given is let's estimate the integral 3.2 integral 2.0 1 over x dx using Simpson's 3/8 rule with h equals to 0. So step 1. Set up the formula and interval. We have a equals to 2.0, b equals to 3.2, h equals to 0.2, and to obtain n, we should do b minus a over h, which is equals to 3.2 minus 2.0 over 0.2 and equals to 6, which is a multiple of 3. And this is the formula. Moving on to step 2, identify the xi values and calculate fxi by substituting the x value into 1 over x. Step 3, organize the terms for substitution. Substitute these into the formula step by step. 3fx1 plus fx2 plus fx4 plus fx5 is multiplied by 3 as it is an intermediate number, while fx3 is multiplied by 2 as it is a multiply of 3. Step 4, compute the total sum, which is equals to 6.268. Step 5, multiply by the scaling factor. So 3h over 8 equals to 3 times 0.2 over 8, which is equals to 0.075. So 3.2 integral 2.0 1 over x dx in estimation of 0.075 times 6.268 is equals to 0.4701. And the final answer is the approximate value of the integral is 0.4701.
conclude, Simpson rule is a highly effective method for numerical integration, particularly for smooth functions where analytical integration is challenging or impossible. Its efficiency lies in using polynomial approximations, making it a valuable tool in science and engineering. We have explored two key variations: Simpson one-third rule, which uses quadratic polynomials, requires an even number of subintervals and assigns weight into the pattern 1, 4, 2, alternating until 4, ending with 1. This method is straightforward and works well for smooth functions. Simpson 3-8 rule, which applies cubic polynomials, requires the number of subintervals to be a multiple of 3 and assign weights in the pattern 1, 3, 3, 2, alternating as needed, and ending with 3, 3, 1. This variation is especially useful for more complex functions requiring higher accuracy. In summary, the choice between this method depends on function's behavior and problem requirement. That's all from us. Thank you.